Hi again. So what we've got here today is a 1541 that is not behaving itself. If I turn it on and try to load something, it's going to give me a device not present error. We'll try that in a second, but I want you to watch carefully what happens when I turn it on. Okay, right now the drive is off. Watch the lights when I turn it on. They both flash briefly and then go out. Now, if I put the microphone over by the drive, you can hear that the motor is still spinning. I don't know if you can hear that or not, but the motor is still spinning. Okay, so the drive is still on. I can still hear it humming away in there. So let's put in a disk, and let's see if we can get a directory. Device not present error. Well, let's make sure that nobody was just fiddling around in there and change the device number. Doesn't work on 9 or 10 or 11. So we don't have a case where somebody just changed the device number and maybe knackered the LED while they were at it. There's clearly something else going on. So let's get this thing to the bench, get it apart, and see if we can figure out what's wrong with it. Generally, when I see a device not present error, my first thought is that the problem is like with the 6522 chip. Now, the 6522 is the VIA, or the Versatile Interface Adapter, and the 1541 has two of them. The one in position UC3 controls the serial communication between the drive and the computer. If that fails, you'll get a device not present error, and the 6522s do fail pretty regularly. However, when the fault is in the 6522, the green power LED stays on and the red status light stays off. That's not what this one is doing. Remember, when I turned it on, both lights briefly flashed, then both went off. This suggests to me that the problem might be somewhere in the power circuitry and not necessarily a bad 6522. Of course, if the power circuits have failed in some way, there's always the possibility of an overvoltage that could have fried the 6522 or other components on the board. So thinking along those lines, I'm going to open this thing up, plug it in, and test voltages at various points on the board. Specifically, here's what I'm going to be looking at.
First, there should be 5 volts on pin 20 of the 6522s. I'm going to check both 6522s for this. I don't think the VIAs are the problem. I just want to see if they're getting 5 volts. Second, I'll check the 5 volt voltage regulator in VR2 and the 12 volt regulator in VR1. If either of these is the problem, I suspect it'll be the 5 volt. And 3, I'm going to look at the bridge rectifiers, also known as diode bridges. Now basically this is just a group of 4 diodes which only allow current to travel in one direction. So they're placed just after the transformer, and what they do is they convert AC to DC. And there's one on each line coming in from the transformer, one on the 12 volt and one on the 5 volt. So again, if there's a problem, I suspect it'll be on the 5 volt line in CR1. Now I suspect that the problem is most likely in the regulator or the rectifier. But if those test out fine and the VIAs look good, then there's a couple of other possibilities jump to mind. Number 4, the logic chip in UB1 is a 7406, and those are known to fail. This chip often causes the computer to lock up or fail to load, but it can also cause a device not present error if it's really buggered up. But because we're not getting that green LED power light, I don't think this is probably the cause. And 5, if it is a power issue, it's possible that there may be faulty capacitors in the circuit. These should be fairly obvious, and I'd probably see them as soon as I take a good look at the board. But I'm going to recap the board anyway, so if I get to this point and I still haven't found the problem, I'll recap and see if that makes a difference. But anyway, you know what they say about the best laid plans. So let's get this thing open and see what's going on.
Okay, before I start flipping this thing over, I'm going to put a transit card in there just to protect the heads. And Commodore had a couple different styles of these that they used with the drives. I made my own. So I'm just going to put this in. And that just gives the heads a little bit more protection as I'm flipping the things over. And now with the screws out, we can just pop off the case. Okay. It looks like somebody may have been in here before because this capacitor does not match the others. That's interesting. Okay, let's get this metal shield off and see what else we can learn. We've got 2 screws on this side, and then on this side there's just a couple of dimples that hold it on. Let's take a quick look at the board. Looks pretty clean. Okay. I don't really notice anything obviously wrong here, except it's kind of odd that that capacitor seems to be a different style than the other ones. But if we take a quick look around here, we've got the 6502. This is manufactured by Rockwell. MOS Technologies, which made the 6502, licensed the design to Rockwell and one other company whose name escapes me at the moment. And we've got a couple of 6522s here. These are the VIAs. Okay, some logic chips scattered around. Okay. So let's plug this thing in and do some voltage tests and see if we can figure out what's going on. Okay, now, like I said before, the first thing I'm going to do is test the VIAs and see if we're getting 5 volts there. So let's turn the drive on after I take the transit card out. Now we'll turn the drive on. So the spindle motor is spinning. Okay, I'm going to try to get a couple shots of close-ups here of testing these chips. Now, the board is on, so we should have 5 volts on pin 20 of the 6522. Pin 1 here is ground, and we've got nothing. And nothing. And we should also have 5 volts on pin 8 of the 6502. And again, pin 1 is ground, so I got nothing there either. So it doesn't look like we've got power really anywhere on this board. In order to figure out what's going on there and get a closer look, we're going to have to take this board off and flip it over and look at the underside. So we'll start by turning it off. And I'm going to go ahead and remove these connectors here. Now we've got 1, 2, 3, 4, 5 screws on top, and then there's 2 more over here by the voltage regulators. Alright, turn it this way, and just flip it over. You'll notice I left this is the power connector, so I left that on. All right. Bottom of the board looks okay. A lot of excess flux over here and around the voltage regulator pins. Okay, so the first thing we're going to do is we're going to test that we've got plenty of power coming onto the board from the transformer. So our power is coming in here, going through the transformer, and coming through these blue and orange wires onto the board right here. So this one right here is our ground pin, and we're going to get power off the 2 on the other end. So let's test our ground pin, and then we've got 7.4 volts and 16.1. So that's good. Now before we go any farther, let's take a look at the schematics. If you look here on the left, you can see we've got our transformer, and then the power goes into the 2 bridge rectifiers at CR1 and CR3. Power then goes through a couple of capacitors to the voltage regulators and then out to the board. Now, I'm not particularly concerned about the 12-volt line on the top because the spindle motor was working, and that's a function of the 12-volt line. So I'm pretty sure the 12-volt line is perfectly fine. The problem is the 5-volt line here on the bottom, because that's what drives the electronics, and that's what we weren't seeing anywhere on the board. So if we look at this, we can see that coming right out of CR1, we've got a capacitor at C4. If we test C4 and we've got power, regardless of exactly what the number is, we know that CR1 is good. Then the power goes into the voltage regulator at VR2, and as it comes out, it's going through capacitor C6. So if we've got a good reading on C4 and a good reading on C6, then the problem is somewhere else. If we've got a good reading on C4 and a bad reading on C6, then we know that the problem is the voltage regulator in VR2. Okay, so let's start by taking a look at capacitor C4, which is right here. That's our positive, that's our negative. Doesn't really matter what reading we get, we just want to make sure we've got power. 12.58. I'm happy with that. Okay, so we have plenty of power coming through the bridge rectifier. Now, let's test on C6 and see what that tells us. Now, C6 is right here. It's not a polarized capacitor. So we should be getting 5 volts here because this is the power coming out of the voltage regulator. 0.37. That is not what we want to see. For comparison, let's take a look at the other capacitor in the similar position on the 12-volt line, which is C3. Now C3 is right here. So if we test that, we should be getting approximately 12 volts. 11.95. So a little more confirmation that our 12 volt line is good and that our voltage regulator then in VR2 is probably our culprit. So VR2, the 5 volt regulator, is here. So I'm going to desolder that, and I think I've got a replacement. Alright, well apparently I don't have a spare 5 volt voltage regulator. I've got a spare 12, but not a spare 5. So while I'm waiting for that part to get here, I'm going to go ahead and clean this up. I'm going to change all the electrolytic capacitors, and I'm going to pull the drive mechanism and change the drive belt that's on the underside. These things have been in here for 30 years. It's about time that we did some future proofing and change those out so that it'll last another 30 years. Okay, so the first thing I'm going to do is the recapping, and I'm not going to show that because it's not really all that exciting. All you have to do is identify the pins on the bottom of the board, desolder them, replace them with identical ones. The only thing that, and you do have to make sure that you've got exactly the right microfarad rating. So like on this big one here, it's 6,800 microfarads. That has to be the same. The voltages can be higher, but they can't be lower. So this one is 25 volts. I could replace this with a 6,800 microfarad 50 volt, and that would be just fine. I could not replace it with a 6,800 microfarad 16 volt. Okay, so you can always replace it with a higher voltage, but never with a lower voltage. And I personally don't like to go much higher than what's already in here, so I might replace a 25 volt with a 35 or even a 50 volt, but I wouldn't replace it with a 100 volt. That's just me personally. So I'm going to go ahead and do that first, and we'll be back when that's done.
One more thing I want to add here. Under the large capacitors, there's usually a big glob of glue. You can see that clearly in this picture. And both of the large caps have this. I'm not really sure why they did that. I'd guess because they were afraid that the caps would wiggle when the drive was moved around during shipping, and that would lead to broken solder joints. But I don't really know. So to remove the cap, we got to get through the glue. Now generally after I've removed the solder from the pins, I use an X-Acto knife to scrape the glue away from the cap, making sure not to scratch the board, and then wiggle the cap free. Getting the glue off the board after that can be a bit of a challenge, but what I usually do is I soak the glue with denatured alcohol and then let it soak in a bit, and then I may have to do it a couple of times, but then the glue can usually be scraped off gently without any damage to the board. I'm kind of meticulous when it comes to glue on these things because I've had glue on 128 power supplies actually corrode components and make the unit non-functional. I've got a video on 128 power supply repairs. Go watch that if you want to see what I mean. So I try to get as much of that crap off as possible.
Alright, so the next thing I'm going to do is change the spindle motor belt. Now in order to do that, I've got to take the entire chassis out of the bottom case, because to get the drive mechanism out, I have to take out 4 screws, and they're kind of down here on the sides, and I can't get to them because of the case. So we have to take the whole bottom chassis out first. It's pretty easy. There's just 3 screws on each side. Screws out, we just lift this out. Set the bottom part of the case aside. And now we can see the screws that hold the drive mechanism in. And then the drive mech will kind of lift up and slide right out the front. Just make sure that you're not catching any of the wires on the chassis. Now we just flip it over. You can see here we've got the stepper motor. This is what drives the head in tiny little increments. This is the motor here. Right, this is our spindle motor. And the belt drives this pulley which spins the disc. And over time this little rubber belt here can get stretched out so that it's not effectively spinning the disc as well as it did. So all we have to do to change that is just lift it off the pulley. Okay. Now here's the new belt, and I got this from Console 5. Now let's just take a look here. You can see the difference in size, simply because the old one has gotten stretched out. So to put the new one on, just hook it over the pulley on the motor, get it on the pulley here. Just want to make sure that it's on evenly and in the middle of the pulley. Okay. And that's all there is to it. And while I have this out and easily accessible, I'm going to go ahead and clean the head. A little isopropyl alcohol here. Head looks to be pretty clean. You see there's really very little on the Q-tip. Okay. And I'm going to put a little bit of lubricant on the rails. Now, I use liquid bearings. It's designed for electronics. I'm just going to come in here and put about 1 drop rail in front, 1 drop behind, and we'll just move the head One of the things I like about this oil is that it's got this small applicator nozzle so that you can get just a tiny little bit and not use too much. Okay. Just a little bit here. Move this out a bit. Okay. And since this is out of the chassis, there are 3 more little capacitors here that I should probably change. Okay, and while I've got this out and easily accessible, I'm going to go ahead and change these 3 capacitors here. And this is pretty easy to do. You just have to take off these 2 screws and this little one. There's a little white bushing here. You got to make sure you don't lose that. And then you'll be able to just lay the board off. I wouldn't take these wires off because there's no real need to, and it just would complicate the process. And that'll just lift up and lay over. Now, if you look here, you can see there's some red colored glue that's holding these down. So we have to be careful getting those up.
Okay, so I've changed those capacitors and put this part of the drive all back together. So now I just have to wait for that voltage regulator to get here from Sweden. I ordered it from a company called Retrotech out of Sweden. So I'll put the link in the description down below in case anybody else needs a 5-volt voltage regulator.
All right, well, my parts arrived from Krister Anderson at Retrotech. Thank you, Krister. So let's open this up. Okay. So what I've got here are 3 of the 5-volt voltage regulators. Figure if I'm going to buy them, I might as well get a few of them. And then a couple of the bridge rectifiers, just in case. I shouldn't need them on this project, but if I do in the future. So let's start by removing these things. Now the 5-volt is here. Okay. So what we have to do first is desolder the pins, and then we can remove these little nuts and unscrew it. Should come right out. Okay, so I desoldered the pins and removed the nuts, and you can see it's already just falling right out. Okay, so the heatsink popped off with it. That's okay. We'll clean that up and put it back on. Okay, so I've cleaned everything off, and what I'm doing now is just putting some fresh joint compound in here just to help with the heat dissipation. And what I'm using is called thermal coat, but there's a lot of other brands and types out there that can be used just as effectively. Okay, and if you notice, the pins are offset a little bit to one side, so we just have to make sure that they are aligned properly. Get that pushed in. Of course, I got joint compound on my fingers, so now it's getting everywhere. Trying not to get it on my fingers, but since I already have, what the heck. I keep calling this joint compound. It's thermal joint compound. It's not glue, though. It's like a paste that you put on there, and it helps to spread the heat out evenly through it so that it works a little better. And now we just make sure that we're lined up on here. And there we go. All right, I'm going to clean that up a little bit and resolder those pins. All right, so I've changed out the voltage regulator. And the power is on. Let's see if we've got power on the board. We're going to start by testing the 6522s. We should have 5 volts on pin 20. Pin 1 is ground. 4.98. That's pretty good. What about the other one? 4.98. And the 6502 should have 5 volts on pin 8. 4.98. All right. Let's hook everything back up and see if we still get that device not present error. All right, so I've got the drive hooked up here to my 128. It's plugged in. I've got a disc in the drive, so I'm going to turn on and see what happens. Well, we're making progress. The lights are both on. Remember last time they both flickered on and went off and stayed off. Problem is the spindle motor is still running and the red LED activity light here is still on, so that's not normal. Let's turn the computer on, boot up in 64 mode, because after all, if we're testing at 1541, we really ought to be in 64 mode. Now let's see what happens if I try to get the directory. And the spindle motor is still running. Get stuck at searching for, and the head has not moved. Okay, so obviously we still have a problem here. Let's see if we can figure out what might be causing this.
Okay, so let's think about our symptoms here. First, we know that the red LED activity light stays on. We know that the spindle motor is continuously running, and we know that the drive isn't responding to commands from the computer. All right, so what could be causing these symptoms? Well, there's several logic chips that could potentially be a problem, but some of the more prominent chips could also be the source of the problem. So, for instance, the 6502 could give these symptoms in certain failure modes. The 6522 in UC2 controls the motor. And the other major chip that could be an issue is the DOS-ROM. That does fail fairly commonly, and that could also give us these symptoms. So what I think we're going to do is all the major chips on the board are socketed. So it's a very simple thing to just swap some of them out and see what happens. So let's start with that. Okay, so I swapped out the 6502, I swapped out the DOS-ROM, and I swapped out the 6522 in UC2, and none of those had any effect. So, the only things left to look at are the logic chips. There are 5 logic chips that could potentially cause the symptoms that we're seeing. Of these 5, only the chip in UD5 is socketed. So as that one will be fairly easy to just swap out with another working chip, I'm going to start with that one.
Well, I've got it working. Drive is off. Let's turn it on. Watch the startup sequence. Perfectly normal. Load a directory. Everything is good. The culprit was the logic chip in UD5 right here. It's a 74LS197, and wouldn't you know, I didn't have one of those as a spare. So I had to take it out of one of my working 1541s just to test it. It is kind of lucky though, because of all the logic chips on the board that could have been a problem, on this board that's the only one that was socketed. So I only had to desolder the one out of my good board. The problem chip here, this 74LS197, is also known as a 74177 timer chip. And basically what that does is it takes a 16 megahertz signal that's generated on the main board and divides that by 16 and provides a 1 megahertz frequency signal to the 6502 to act as the clock for the board. Alright then, so with the faulty 5-volt voltage regulator replaced and the faulty logic chip replaced, we've got a working unit here that's good as new, all new capacitors, a new drive belt. Hopefully this thing will last for another 30 years without any other maintenance. So let's get it put back together and call it a night.